I'd like you to do a thought experiment right now, wherever you're sitting. Answer this question. How far up are you? What did you measure yourself against? Did you think about how far up you are from the chair? From the floor? If you're in a building with multiple floors, how far up you were from the ground floor of the building? How far up you were versus the floor above you? That's still a legitimate way to measure yourself and see how far up you are. You could have measured it against the bedrock, it could have been against a basement level, it could have been against the center of the planet. The key thing is, all of those versions that we just talked through were all about potential energy. And in each one of those, the way that you define your absolute internal energy is going to give you a different value, depending on what you're measuring it against. So internal energy is going to be the sum of your potential and kinetic energies that you have in a system. However, we care about the difference between where it's going to start and where it's going to end up. That's going to be our delta E, our change in energy. And just remember that delta, it's a capital delta in our case, means change in. So anytime we see delta E or delta anything, it means change in whatever it was. Now, if we set that up, we're going to be looking at how far apart our initial and our final status is going to be. And depending on what order we put them in, we'll fix the sign the way that we'd expect it to be. Also, I'll point out that if we're talking about a chemical reaction, if we're talking about our reactants and our products, if we look at how far apart those energies will be, that'll tell us a little something about whether or not we have to put energy into the system, or if we expect the system to give up energy when it has that change occur. Now let's see it conceptually, and then we'll see it graphically as well. So please pause the video for a moment and answer this question. If you have coffee cooling in a room, what are you going to define as your system? What will you call your surroundings? And which is going to be larger, your initial or your final internal energy? Go ahead and pause and try it now. Okay, let's take a look. Now, my coffee is definitely going to be part of my system because that's what I'm going to be caring about. Or is it? What if what I care about is how much having this hot cup of coffee sitting on the table is affecting the analytical balance nearby by causing thermal eddy currents like you've seen in the lab course? Really, it's often intuitive what we want to call the system, but sometimes we have it backwards. And sometimes we will need to flip our understanding thoroughly on its head. We always will have to be careful about our reading of the scenario. I'm going to decide to call the system my coffee. That means I'm going to call the air around it the surroundings. Now, the other thing I've got to decide for myself now, am I going to consider this coffee cup to be part of the system or part of the surroundings? And the answer is it depends. What am I actually trying to solve? If I'm solving for how quickly my coffee is cooling down, I probably care about the heat lost by the coffee and transferred into the cup. At which point I'm going to call the cup and the dish and maybe even that spoon there part of my surroundings. However, if what I was concerned about is how much setting this coffee cup onto my expensive new table, if I'm worried about how much heat is being deposited into that table because I'm worried about thermal damage of the table or something like that, then the cup would be part of my system as well. So we always have to think through exactly what question we're really trying to answer in the bigger picture before we can answer the question at the small picture of what's my system and what's my surroundings. Now, let's also switch gears for a moment. Oh, I was going to do this first too. All right, which is larger, energy initial or final? And it depends. For the coffee, I would say that for coffee, my initial energy is going to be higher because it's cooling down. However, it's larger for my cup and for the surroundings. So delta E went up there, delta E is going down there. Now, let's also just go ahead and think through it graphically because that's going to make things a lot more straightforward to think about. If I've got something that's hot and energy is flowing out of my system, it's going to be flowing into the surroundings. I've lost energy from my system as it was going to the surroundings. I went from hot at high energy to cold at lower energy. And that transition will tell me that the sign should be a negative sign. Now notice when we come back up here, if my final energy is lower than my initial energy, that means this is going to be the big number, this is going to be the smaller number, and that means we'll have a negative sign. So you can always think through it graphically if it's hard for you to remember which order it goes in mathematically. And in fact, that is how I think about things when I'm working through chemistry and thermochemistry. I like to think through things as, where am I before? Where am I after? Did it lose energy? If so, it went down. That's a negative sign. Now, conversely, let's look at the surroundings. The surroundings started out colder, ended up hotter. That's going to be a positive sign, a positive change in its internal energy. And that means it'll be a positive delta E. And I'll just put a plus sign there because we didn't specify any values. Similarly, it would be what you see right over here. That's how we're going to be thinking through internal energy and through our delta E. Now, let me tell you, please be very careful with your signs whenever you're trying to solve a thermochemistry problem, because that's the number one issue that I see throughout not just undergraduate work, but even in graduate work and published articles. We often see that people have gotten their signs wrong, and if you get the sign wrong, it actually means the exact opposite of what you're trying to say.